This lecture video covers the first half of Chapter 7, and we're going to look at the economics of input, and then the second half will cover product substitution. So a few key terms that we're going to be looking at in this section are just these first three. So we're going to look at isoquant, marginal rate of technical substitution, and the isocost line. The isoquant curve, we're looking at things from a production standpoint, so from a business who's producing products to sell, rather than a consumer standpoint, which the first few chapters of this textbook, we looked at everything from a consumer standpoint. So at this point, we are now going to look at two different inputs and thinking about the producer utilizing two different inputs to create their output or their product that they're going to sell. So the isoquant curve represents various quantities of two different inputs that will produce the same level of output. So the two different inputs that we're looking at are labor, which we looked at that in previous chapters. So, that can be measured in hours of human labor. It can also be measured in wages paid as well, but we'll consider it as hours. And then the second input that we're looking at is capital. So capital is going to just be the combination of basically all costs that are not labor costs. So that can be technology, machinery, fuel, fertilizer, feed, etc. So any combination of capital, units of capital, combined with units of labor that lie on this single line will produce the same level of output. So if we use 8 units of capital and we're going to pretend that lines up with 1 unit of labor, that's going to produce 10 units of output. If we use 2 units of capital and 4 units of labor, that's also going to produce 10 products or 10 units of output. Similarly, if we use 4 units of capital and 2 1/3 units of labor, that's going to also produce 10. So every single point and combination along this line is going to produce 10 units of product or 10 units of output. And then higher production isoquant curves will exist to the right and higher. So this isoquant curve is producing 20 units of output. So every combination on this line is producing 20 units of output. So this is very similar to the indifference curve that we studied in Chapter 3. We were looking at consumer preference of two different goods and the amount of satisfaction that they would provide. Now we're looking at two different combinations of input and how much product we can produce with them. Utilizing the isoquant curve, we're able to calculate the marginal rate of technical substitution. That's going to tell us how much labor we can substitute for a given unit of capital, or how much capital we can substitute for a given unit of labor in order to produce those same levels of output. This is basically just a measure of the slope between 2 points on the isoquant line. So marginal rate of technical substitution, how we're going to calculate that, the equation is just change in capital divided by change in labor. So we could do, or change in input 1 divided by change in input 2. So change in capital divided by change in labor. How we could write that out a little bit more is capital value 2 minus capital value 1 divided by labor value 2 minus labor value 1. And that's going to be able to give us those changes. So let's calculate a couple of those. But before we do that, here's an example a little bit more of what that means. So if we're planting an acre of corn, and we're producing, let's say, 175 bushels per acre, we could hand plant all of that corn, and maybe that would take 60 hours, possibly more, to go out there and hand plant that. So that would be labor. Or we could use capital equipment, fuel, machinery, a mechanical planter to plant the same corn. So the marginal rate of technical substitution is going to tell us how many hours can we substitute per 1 unit of capital to create the same output, or how much, or vice versa. Okay, so let's look at a couple calculations. So on this graph, we want to find what is the marginal rate of technical substitution in range A. So basically from going from point G to, we have an unlabeled point down here. So how we are going to calculate that, so it's going to be capital 2 minus capital 1 divided by labor 2 minus labor 1. So if we label this as 1 and this is 2, our capital at point 2, let's look at that one first. So our capital at point 2 is 4. So we have 4 minus our capital at point 1, which is 8. And we're going to divide that by our labor at point 2, which here is about 2.3, we'll say, minus our labor at point 1, which is approximately 1.3. So we have 4 minus 8 is -4, and then 2.3 minus 1.3 is 1. So in this case, we would have to give up 4 units of capital. We would substitute that for 1 unit of labor. So in this case, and that's why that's negative there. In this case, actually 1 unit of labor is worth 4 units of capital. 4 units of capital is worth 1 unit of labor. So the MRTS in range 1 is -4. Now if we calculate for range B, we're going to use that same equation. So for range B, let me erase some of this. We're going from 3 to 2, and then 3 to 4 here. So we'll label this as number 1 and this is number 2. So capital at point 2 is 2. Capital at point 1 is 3. Labor at point 2 is 4. Labor at point 1 is 3. So 2 minus 3 is -1. 4 minus 3 is 1. So marginal rate of substitution is -1, which means that at that point we would trade 1 unit of labor for 1 unit of capital in order to get the same amount of output. And then the last example at range C, got a tighter fit here. Okay, so range C is really small. It's this line and this line. So it's this point and this point. So we'll do point 1, point 2. So point 1, capital use at point 2, capital use is, if we follow that all the way over, we'll say 0.3, so 0.3. Capital use at point 1 is, we'll say 0.6. Labor use at point 2 is 7. Labor use at point 1 is 6. So we have 0.3 minus 0.6, which is going to give us a -0.3. 7 minus 6 is going to give us 1, so that's approximately 1/3. So we would trade 1 unit of labor for 1/3 of a unit of capital, or 3 units of labor. If we multiplied that, it'd be 3 units of labor for 1 unit of capital. Okay, so marginal rate here is going to be 0.3. So this is the marginal rate of technical substitution of labor, nope, sorry, of capital for labor. Because in this case, we'd give up 4 units of capital to get, or we would trade 4 units of capital for 1 unit of labor. We'd trade 1 for 1, and here we'd trade 1/3 unit of capital for 1 unit of labor. So the isoquant lines tell us the different combinations of 2 different inputs, in this case capital and labor, that will give us the same number of outputs or the same number of products produced. However, it does not tell us the least cost combination or the cost at all of any of these combinations. So in order to figure out how much these cost, and to find the least cost combination, we need to look at the ISO cost line. So the ISO cost line is going to provide us all of the different combinations of 2 different inputs, capital and labor, that cost the same amount of money. The ISO cost line does not tell us how much we're producing with each of those combinations, but it's just telling us that, for instance, 5 units of capital and 50 units of labor costs the same as 10 units of capital and 0 units of labor. So every single point on this line costs the same amount of money. This is similar to the budget line that we looked at in Chapter 3. So when we were looking at hamburgers and tacos, we were figuring out all of the different combinations of hamburgers and tacos that we could buy for a specific budget. This tells us all of the different combinations of inputs that we can use for a single price. Given the ISO cost line, we can figure out some things. So here's an example. If we're given the ISO cost line for Frank down here, who's a strawberry producer, and we know that Frank basically has a budget of $1,000 to spend on inputs in order to grow an acre of strawberries. So if we know that he has a $1,000 budget and we know what his ISO cost line looks like, we can figure out what labor costs for Frank and what the capital cost is for Frank. So we can answer this right away. How much does 1 unit of capital cost for Frank? Well, if he's spending $1,000 and if he spent all of that $1,000 on capital, he could buy 10 units of capital. So to figure out how much capital costs, we're just going to take that $1,000 and divide it by 10. That's going to give us 100. So we know that capital is $100 per unit. If Frank spent that entire $1,000 on labor, he could buy 100 units of labor. So if we take 1,000 divided by 100, we're going to get 10. So we know that labor is costing him $10. All of these various combinations exist on this line and have been transformed into this table. Okay, so we have 9 units of labor, or 9 units of capital. We have to figure out how much labor that would match with in order to cost $1,000. So how we can calculate this out is we know that capital costs are, erase a little bit more here. Okay, we know that the capital costs are $100, so 10 times 100, that's $1,000. So if he's already used all of his $1,000, we know that he can use 0 units of labor in that case. If he uses 9 units of capital, we know capital is $100, so that's going to be $900. He has $100 left to spend on labor. Labor costs $10, so if we divide that 100 divided by 10, we know he can use 10 units of labor. So 9 units of capital with 10 units of labor. If he uses 8 units of capital. We know capital costs $100, so that's going to take 800 of his dollars. 1,000 minus 800 is 200, so he has now $200 left to spend on labor. Labor costs $10 a unit, so that means he would be able to buy 20 units of labor left with that. So you can go ahead and continue calculating those down in that same way and fill out the chart. You can use this equation too if you understand this a little bit better. So $100 times the use of capital. So if we did, let's do number 7 in that. So $100 times 7 is 700. We need to add that to $10 times X, basically. We don't know what that is. So we can subtract 700 from this side, and that's going to give us 300 that we're left with. So now our equation looks like 10 times something equals 300 divided by 10 divided by 10. We're left with X equals 30. So that's going to give us 30 for that box. You can kind of think about it in 2 different ways. But this is just giving us the different combinations of capital and labor that are going to cost $1,000, and that's what makes up every single point on the ISO cost line. So we can make some changes to this. So if Frank's budget for input expenses increases to $2,000, what effect would that have on his ISO cost line? So remember his original ISO cost line, we have capital and labor, and we had 10 and 100. If his input expense budget increases to 2,000, so this was at a budget of 1,000. If it increases to 2,000 and all the other prices stay the same, so we have 2,000 divided by, we knew that capital costs 100, labor costs 10. So if we have 2,000 divided by the capital cost of 100, we're going to get 20 units that we can purchase. So this line is going to change to 20, and then our extreme point for labor, 2,000 divided by 10, is going to give us 200. So this point is going to come out here to 200, and that is your new ISO cost line. So the effect that it has, it's going to shift to the right. Okay. Suppose Frank's budget for input expenses decreases to 500, draw the effect that this would have on his ISO cost line. Okay, so again, we have the capital and labor. When his budget was 1,000, we had 10 max capital, 100 max labor that we could buy. But if his budget is, and we had capital cost $100 and labor cost $10. Now if the budget was $500 and he spent all of his money on labor, he would be able to pay for 50 hours of labor. So this would be the new extreme point on labor. If he is 500 and capital is $100, he would only be able to do 5 units of capital. So now his new point is here, and the budget basically shifts to the left. Okay. If labor costs double to $20 per unit, draw the effect that this would have on the ISO cost line. Okay, so again, capital, labor, we were at 110. That's when the capital cost was $100 and labor was 10. and the budget is 1,000. So budget is staying at 1,000, but now the labor costs $20 instead of 10. So you divide that by $20 and your new extreme point for labor is going to be 50. Nothing changes with capital. So your new line is going to look like that. We did a lot of this with budget lines before. Okay, I'm going to let you figure out this last one. Suppose the cost of capital decreased to 50. Draw the effect that this would have on the ISO cost line. So go ahead and make that change in your notes as well. This summarizes the first two examples that we did. So if the budget doubles, the ISO cost line is going to shift to the right, and each of the extreme points are going to double. If the budget cuts in half, which is when we went from 1,000 to 500, the ISO cost line is going to shift to the left, and each of the extreme points are going to cut in half as well. And here we'll actually see some of the answers of the first one. So if the cost of labor cuts in half, so if it goes from $10 to $5, we're actually going to be able to increase our labor extreme point. If the labor gets more expensive, as it did in that third example, we're going to decrease our labor extreme point. And then this one shows the effects of changes in capital. So if our capital price cuts in half, we're going to be able to increase our extreme point for capital. And if our capital price becomes more expensive, we're going to be able to afford less. So that extreme point would decrease. So we've got some true or false questions here. So when the ISO cost curve is shifting to the right, what is happening? Well, when it's shifting to the right, we're having a change in budget. So we're spending more, and we're spending more money because we have more money to spend. So we're buying more capital and we're buying more labor, but price is not changing on either of them. So we are increasing the amount of labor that we are inputting. Yes, that's true, because we have more money to spend, so we're going to buy more labor. We are increasing the amount of capital we are inputting. That is also true. We have more money to spend, so we're buying more capital. We are increasing the amount of output we are creating. Yes, that is true, because the more input and the more inputs that we have, the more outputs that we're going to have most of the time if we're on the upside of the curve. We're increasing the cost of capital per unit. No, we are not changing the price of anything. If we're changing the price of something, then things would shift differently. We are increasing the cost. No, that's not true. We're not increasing the cost. And we are increasing the amount that we are spending on inputs. Yes, this is also true. In total, because we're buying more, not because they cost more, just because we're buying more. So the ISO quant line gives us the combination of two different inputs, different combinations of two different inputs that produce the same level of output. The ISO cost line gives us different combinations of two different inputs that cost the same. When we put these two together, we can find the cheapest combination of the two different inputs to produce a specific output. So if we wanted to produce 20 units of product, and we also have an ISO cost line, then we can figure out the cheapest combination of capital and labor to create those 20 units. Where the ISO cost line meets or falls tangent to the ISO quant line, in this picture it's point G, that combination of labor and that combination of capital is the least cost combination of inputs. This is also where the two slopes of those lines are exactly the same. It's where they're tangent to one another, okay? If we want to find then, for this graph, what the actual lowest cost combination is, we would take the cost of labor times the number of units of labor plus the cost of capital times the number of units of capital that we use, add them together, and that will give us the lowest cost that we can possibly create a certain number of units of output, in this case 100. For example, if we assign some values here to labor 1, let's say labor 1 equals 50 units and capital 1 equals 20 units, and we know that labor costs $10 per unit and capital costs $30 per unit. When we're asked what is the least cost input for 100 units of output in the example provided. Well, again, we've found out that point G is the least cost combination because that's where the isoquant curve meets the isocost line. So now what we need to do is we need to take the labor quantity times the labor cost plus the capital quantity times the capital cost. So labor quantity is 50 and the cost per unit is 10. Capital quantity, we're going to use 20 units of capital, and that costs us $30 per unit. So 50 times 10 is 500, 20 times 30 is 600, so the total cost of all of the inputs is going to be $1,100, and that's going to be the least amount of money that we can spend in order to create 100 units of output. So here's one of the problems that you're going to have to do for your homework. Suppose the wage rate for labor is $20 an hour and the rental rate is $50 an hour. Based on this information, answer the questions below. So draw the ISO cost line associated with an hourly budget of $1,000. Okay, so we have $1,000 to spend, and we know that the wage rate is $20. So if we spent all of our money on wages, we would be able to purchase 50 units of labor. So that would be our extreme labor point right there. Okay, if we spent all of our $1,000 on capital, we would be able to, we'd take 1,000 divided by 50, we'd be able to purchase 20 units of capital. So that's going to give us a line that looks like that. So that's the ISO cost line that's associated with that budget. That's what we're looking for. What is the least cost level of capital and labor this business should utilize when packaging 1,000 cases of fruit juice? So we're looking to produce 1,000 cases. This is our ISO cost line. And we need to basically move this parallel until it becomes tangent. So the best way to do this actually is to take a piece of paper and sort of just slide it up to the point where it meets tangent. I'm going to try to do the best that I can here by just drawing a series of parallel lines, but they're not going to be perfect. And as we slide it up and slide it up, we're going to become parallel close to about this point. Okay, so that's going to become, or tangent, sorry, not parallel. That's going to become tangent close to this point as we slide it up. So that's going to be at about 50 units of labor, and if we draw a straight line over, 38 units of capital, approximately. And your numbers might be a little bit different if you slide it differently, but we're just estimating here because that's the best we can do with this sliding method. So what is the least cost level of capital and labor this business could utilize? 50 units of labor and 38 units of capital. How did you arrive at this answer? Basically, you can just say that you slid, you made the original ISO cost line and then you moved it parallel until one point on it became tangent with the ISO quant line. We're not going to go over these answers here, but these are some of the answers on the quizzes that will relate right back to the information that we just went over. So just to have those on your radar, it might be a good time to answer them while this stuff is fresh in your head. And then you have questions 1 through 4 to complete in your textbook, which is on pages 130 to 131 for the problems for this week. Just we'll look at them really quick. I won't go over the answers, but this one is asking you to plot an ISO cost line. So you're given the input budget and then the price of each of the inputs. So hopefully you can calculate those extreme points and then make your ISO cost line. And then don't forget to answer what's the value of the slope, which again, the slope is also going to give you the marginal rate of technical substitution. Because that's the same thing. The slope is the same as the marginal rate of technical substitution. So make sure to answer that. We looked at these values. Basically, this is just asking you to kind of fill in the blanks of what's going on. These are changes in, we need to figure out, are they changes in budget? Are they changes in wage rate, labor rate? Are they changes in capital rate? So that's what's going to be labeled in these boxes, what the change is, and then whether they are what's being halved, what's being doubled. So you can kind of go back and look at those graphs that we looked at earlier in lecture and fit that information in. Number 4 is asking you to calculate the marginal rate of technical substitution between points A and B. We did those ranges calculations earlier in the lecture, so go ahead and look back at that. And then calculate the marginal rate of technical substitution for D and E. So, that's that change in capital divided by change in labor, which actually was, capital 2 minus capital 1 divided by labor 2 minus labor 1. So you can go ahead and calculate those values. And with that, we're not doing number 8. So that's it for this week. As always, reach out if you have any questions, and good luck.